Ladies and gentlemen, here we go with assignment K, the lens equations. And so we've got this set of equations are going to be very similar to the mirror. In fact, they're exactly the same. And so with this set of equations, you've got to know if the lens, is convergent or divergent. And knowing that, let's see, change the pen color to blue. And so again, all these letters, variables, mean the same thing. This is going to be distance between the object and the mirror and the lens. It's always going to be positive. Q, distance between lens and image, or image and lens. F is the focal point. M is magnification. If I can spell. And then H prime is image height. And H is object height, or whatever dimensions we're looking at. And so all this is what we're going to be looking at today. Same set of equations we were working on last week, or before spring break. Now the conditions, we're looking at a convergent lens. Basically, the lens is going to look like this. P is going to be positive, always. The image is on the other side of the lens. So here's my object. The image is going to be over here. Q is going to be positive. F is positive, and the image is real, and it's going to be flipped. If the image is on the same side of the object, Q is negative, and the image is virtual. This is important because what we're looking at, if this is our number line, well, this lens are different from mirrors. So if this is my object, this is my P, this is P, this is positive and negative. Q, on the other hand, is flipped. You need to understand that in order for these to work these lens equations for lenses. If you're done with photography, this is what you need to know. With a divergent lens, P is positive, image is always on the same side of the object, so it's going to be flipped over. Q is negative always, and the image is going to be virtual always. So it looks same side. So now what we're going to do is take a look at a problem. So we've got a small car that is officially allowed in the United States. It's placed upright in front of a converging lens. So we're going to have a car, and I'm going to put on its bumper. There's my car. Looks crappy, doesn't it? Looks like a colon, F and a colon. So the lens, which has the focal length of, here's some data that we're going to need. Oh, image. Oh, it tells me how tall it is and how far away it is. Oh, we got 3 pieces of information. So we've got the focal length is 1.5 meters. Image height is 75 centimeters. I'm going to change that to meters. Divide that by 100, you get the number in meters. And Q is going to be a positive 2 meters. It's going to be positive 2. It is on the other side of the lens. It has to be positive. So we're looking for the object distance, P, which we don't know, the magnification, which we don't know, and object height, which we don't know. So we got 3 pieces of information. Can we find the other 3? Again, realize the first question just giving you setting up the experiment. So let's look at this. 1 over P plus 1 over Q equals 1 over F. Again, F is equal to 1.5. Q is equal to 2. And both are positive. P we don't know. H prime is going to be a negative 0.75. Negative because it's inverted. And then we have magnification, which we don't. And well, that's it. We don't know the magnification. That's what we're going to be looking for. So put the numbers in. 1 over P plus 1 over 2 equals 1 over F. 1.5. Multiply everything by P. So 1 plus P over 2 is equal to P over 1.5 multiply everything by 2. 2 plus p is equal to 2p over 1.5. Okay, multiply everything by 1.5. That's going to be 3 plus p is equal to 2. 1.5 times 2, that's going to be 3p. With p over. So follow me over to this point. Subtract both sides, minus p from both sides. So 3 is equal to 2p. Let's see, did I do that right? Oh, this is 1.5p. And this is going to be 2. So 3 is not equal to 2p, but equal to 1.5p. So 3 divided by 1.5. Should give me 2, which is not correct, because it should be 6. So where did I mess up? Multiply both sides by 2. So that's 2 plus p. So multiply everything by p. So that's 1. P times 1 over p is 1. So that plus p over 2 is equal to p over 1.5. Multiply everything by 2. 2. 1 times 2 is 2. 2 times 1/2 is 1. So that'd be 2p over 1.5. All right, multiply everything by 1.5. This is 2. There we go. It's 0.5. And there we go. There's my mistake right here. Be careful, guys. So this is 3 plus 1.5 is equal to 2p. So subtract 1.5 from each side. You're going to have 0.5 p. Divide both sides by 0.5. You're going to have p is equal to 6. All right, so magnification. If we come over here, magnification is equal to minus q. Whoops. Equal to minus q over p. Magnification is equal to, what we say, minus 2 over 6. So that's equal to minus 1/3, or negative 0.33333, repeating. So now we answer 2. See, this is going to be really easy, guys. Now we need to know what h is, the height. So if magnification is minus 1 over 3, that's equal to q, not q over p, h prime over h. H prime is a negative 0.75, and this is over h. So multiply both sides by h, and then multiply both sides by negative 3. So it'd be h is equal to negative 3 times negative 0.75. And we should get 2.25 meters as the height of our object. There we go. Now you know how to do this. Watch out for your math, because it's easy to mess this up. Trust me, folks. This is what I dot people on. It's not that you use equation, but you make mistakes in doing it, and it's easy to do. So practice these things. This is what the homework's for. Thank you, guys, and we'll see you with the next slide.